sketching a parabola using intercepts. Now I'm going to use this to make us a little checklist or a little step-by-step thing what we need to do, and over here I'm going to explain where it comes from. So the first thing that we need to identify first is we need to identify parabola. The general equation for a parabola, y equals ax squared plus bx plus c. Now, as you've seen previously, it can only be ax squared, it can be ax squared plus c, it can be ax squared plus bx. The moment there's an x squared, then we know that this is a parabola. So the parabola, I'm going to just put in brackets y equals ax squared plus bx plus c. So that's our general equation. The first thing that I always do is to find out, is it a smiley or is it a minimum or a maximum graph? So is it a positive or a negative? So to do that, I'm going to look at the a value. Now, I can either have a smiley face or I can have a sad face. If I have a sad face, I read the parabola, I reach a maximum height. And therefore this is called a maximum parabola, and this is a minimum parabola. Because you can get no value less than a certain turning point here. With that minimum, smiley face, that's the form of ax squared, so this is when a is positive a, and if a is negative, we have an upside down. How I remember it is, if you're positive, you're smiling and you have minimum problems. If you are negative, then you are frowning and you usually have maximum problems. So our first step is minimum, maximum. Minimum or maximum. Okay, and to remember which one that is, if a is positive a, I'm smiling, negative a, I'm frowning. Okay. Our second step is to find the y-intercept. So second step, y-intercept. And remember, on any graph, your y-intercept is where x equals 0. So your y-intercept is always where x equals 0. So what I'm going to do is I'm just going to substitute. If I have x 0, then this is going to be 0, because something times x 0 squared is 0, plus something times x squared is 0. So my answer will always be c. So the y-intercept is always c, unless this is in the factorized form. Our next values that we want is we want our intercepts with the x-axis. Okay, so my third step is my x-intercepts. My x-intercepts is of course where my y value equals 0. So this is where y equals 0. Now there's three ways that I can get this. So the first step is by factorizing. My second step is by completing the formula, or just say completing the square. Completing the square. And the third one is by our formula, by formula. And this formula you should know. X equals minus b plus minus b squared, the square root of b squared minus 4ac divided by 2a. So that formula you need to know of heart. So that's the three ways that I can find the x-intercept when y equals 0. So let me just quickly explain that to you before we go on with that. What you need to remember is the following. If I have anything, and this is equal to 0, it means ax squared plus bx plus c equals 0. So I can find the value for x. And to do that, I either got to factorize, or I got to complete the squared, which most people don't like, or the third one was the formula. And the formula is sometimes the easiest. If you battle with factorizing using Null's law, then this is probably the easiest way, is by remembering this, and then finding the value. There's three different ways that we can find this value. Or not find a value, but what the values can be. I can have either a normal parabola, and it just assumes all is possible, all is positive, A is positive. Then I can have two values, depends on what this is. I've got two values. The second one is when it's actually turning on the line, which means I'm going to have only one turning point. In that case, these two brackets will look exactly the same. In other words, I'll have something like x plus 2 equals 0, which means x equals negative 2, and then that point will be negative 2. The third one is where I do not have any values. Now this is also called roots. These are also called the roots of the factor. So where it goes into the x-intercepts, also called the roots. Now the roots of this function then is imaginary because it doesn't cut the x-intercept, which means that if you factorize, try to factorize, so you try to do North's law, you can't find any answers, and when you use the formula, you get that this value in the bracket, also called the determinant, that this determinant is negative, and if that is negative, it means my answer is imaginary, from imaginary numbers, which means there's no real roots, and it cuts like that. If that is the case, you just need to have the turning point, and to get another point on there, you'll just use symmetry, or you'll just substitute the value in there. So now I have the minimum, the maximum, and minimum, maximum. We've got the y-intercept, we've got the x-intercept. Our next thing that we want to calculate is the turning point. Turning point. That's always important. Turning point. And the turning point's got two values. It's going to be your x value and the x value of your turning point. Now all parabolas are symmetrical, which means that there's a line of symmetry, and that line of symmetry is exactly in the middle, and the distance at any point on both sides are always exactly the same distance away from there. So to find that x value, what you can do is one of the following. There's two ways to find that. Okay, it's going to be a formula called minus b over 2a, which is probably the easiest to remember. That's the first way to do it. The second way to do it is to get halfway between the two factors there. So I'm going to say x1 plus x2 divided by 2. So if you have two roots, it's x1 plus x2 divided by 2. That's very hard to do if you only have, if there's no values there, because then you won't be able to get it. So the safest one is to learn minus b over 2a. The y value, there is a formula, but I don't even feel like writing it down because it's so big. It is c minus, and then the formula is b squared over 4a. And it's so hard to go and remember that. So all I do is, instead of doing this, and I'm just going to put a little red box because I don't want you to really do that. The other way to do that is just to sub this x value back into your original equation. Because remember, you're going to have now a x value, and if you want to know what's the y value at that point, you just have to sub back into that value. And that will give us then all the answers that we need. So minimum, maximum, y-intercept, x-intercept, turning point. Please look at the examples to see exactly how we're going to do that then.